Okay, in this video I will show you that how simply we can generate the data and feed it to our computer systems. Basically, for that experiment I'm using one ESP32 board and one accelerometer, which is just below this particular board, ESP32 board, and the ESP32 controller board is connected to my computer system via this USB cable, and this USB cable is powering this particular board, and the data is collected through a serial plotter in Arduino interface with a baud rate 115200. There are three functions we can see, or three signals we can see. One is blue, red and green. So blue color indicating x-axis, red color indicating y-axis, and z axis data is indicated by green color. So what is this x, y and z? Basically in accelerometer we know there are three different axis data. One is x, which is for my board, this is along this horizontal axis in this particular way, and z is in the in this particular directions is a y, sorry, and z is in the upward directions. So if we just move this particular board and in different directions, the waveforms are changing, right? So I'll be just showing one by one. So this is along vertical axis we have z, and here we can see the z waveform is showing by the green color. So if we just vibrate this particular board or displace this board along the vertical axis, it will be the z axis data is changing. If we just shift this particular board along this x axis direction, the blue color waveform is changing. If we shift it through the y axis, it will be changing the red color. Along with z and x data is also varying because I'm not so precise in moving this particular board to a particular single directions. So now the main objective is that, okay, that three different axis vibrations data is basically captured and showing on the screen. So now I can just create some rhythmic waveforms. So as you can see, if I'm vibrating with a particular rhythm, we can have a waveforms, which is, we can say, some kind of quasi-periodic kind of waveforms. So if we just do some kind of quick vibration on the boards in this way, so we can have different waveforms. So if we just shift like that, so we can have different waveforms. So we can see that very complex kind of waveforms we can generate. And what is the objective of that? Basically the objective is that if you want to study signal processing with the real time data on my computer system, so we can use this kind of setups and feed it to my computer systems, take out individual channel data x, y and z and data, and we can process on individual channel data as well, right? So this is the technique, and just you do whatever you want. You just vibrate this particular board in different directions, you will have different kind of waveforms. So very nice kind of waveforms you can also generate, as I can show it here. Okay, this is very nice, one kind of something like the ECG kind of data we can say as well. So now this is another one. Suppose the board is standing over here. If it is falling down, so we can have specific signature which is basically going around that. If the board is falling down in different directions, so it will be showing some different kind of signatures. So in that way you can find out, even in data analytics applications, you can use this particular board to generate different kind of data, to identify different vibration patterns and recognize it. So obviously for every cases you have to do some kind of processing on the real time data, and that's why it is a very beautiful system by which you can feed the data to your computer systems. And every computer has serial port. If it is not there, you can use your USB port as a serial one and you can collect the data. So that's it for this demonstration. Thank you.